My name's Luke Wainwright. I'm a PhD student at the UCL Institute of Neurology. My project is looking into coenzyme Q10 deficiencies and the blood-brain barrier. Q10 deficiencies result in a mitochondrial dysfunction which can sometimes present in ataxic form. And CoQ10 therapy has been shown to alleviate a lot of the symptoms associated with non-neurological parts of the body, for example, myalgias, lethargy, heart problems. But the results in neurological improvement are sometimes good, sometimes bad. So one of the theories is the blood-brain barrier stopping Q10 getting into the brain tissue. So I'm looking into that. I'm trying to work out exactly how Q10 is getting into the brain. And as soon as we understand the mechanism, the precise underlying science, then we can start to work on improving therapies. So I've been doing a PhD now for 3 years, and there's been some interesting findings. We've certainly narrowed down how it's getting into the brain. How that's going to translate into a product, I'm not entirely sure, because my focus is really understanding scientific mechanisms. We've also seen some effects with statins and Q10, which will relate to ataxia patients. That will be released soon. Can't release too much at the minute, but we've made some headway. We have made some solid headway, and all knowledge can be built upon. And as a fundamental scientist, I think it's important to really understand before you then build something, because you need a solid foundation. So coenzyme Q10 works in the mitochondria. The mitochondria are the powerhouse of the cell. That's where all your energy comes from. As with most things in the universe, without energy, not much is going to happen. And in a life form, that can present as lots of diseases, or in the worst cases, it's just not compatible with life. Within the mitochondria, there's a series of chain reactions along the electron transport chain. Now, it's called the electron transport chain because between each of the reactions, electrons pass through. Q10 shuttles them, so imagine it as like a bus almost, getting you from one reaction to the other. And if Q10 isn't there, then this reaction doesn't complete and you don't get the energy. So that's what Q10 is used for. So Q10 is the natural form that you find in the body, and therefore it's probably the most efficient and recognised by the cell. However, it is very insoluble. It's a lipid. It doesn't like water, which makes it a bit of a tricky one for therapy. So it means not much gets uptaken, and it's hard to formulate into decent therapies, basically. Idebenone is a synthetic form. It's slightly shorter, well, it's half the molecular weight, which means uptake is sometimes easier. And it works in a similar manner. It is targeting the mitochondria, and it does work as a potent antioxidant. But there is more side effects associated with Idebenone. So it's a bit of a toss-up, really. But then again, there is more evidence that it works in, for example, Friedreich's ataxia, because probably of the bioavailability or access to the mitochondria.